Rainwater harvesting and reuse is the most ancient practice for water supply. Examples of systems for rainwater harvesting date back to the Neolithic. The development of a civilization often benefited from the storage of water and its planned use over time. Nowadays, for a large portion of inhabitants in developing countries, rainwater harvesting still represents the main source of water supply. In developed countries, rainwater harvesting and reuse is more and more encouraged since it provides several benefits to water supply and urban drainage systems and environmental ecosystems. It represents an alternative source of water supply for non-potable uses particularly relevant in water scarcity conditions due to climate change and/or the increase of water demand. Rainwater harvesting and reuse also promotes the mitigation of urban floods, reducing peak runoffs and volumes discharged into the drainage system, contributing together with infiltration and evapotranspiration to meet the hydrologic invariance target. Moreover, it limits the activation of combined stormwater overflows and the pollution of receiving water bodies, as well as reducing the withdrawal from highly quality sources. Rainwater can satisfy about 50% of domestic water demand, such as private and public green irrigation, car wash, boiler supply, firefighting use, toilet flushing, supply of air conditioning systems, surface cleaning and machine washing. The elements constituting a rainwater harvesting system are roof, gutter protection screening, gutter, rain head, first flush diverter, tank screen, rainwater tank, insect-proof flap valve, auto-fill system, pump system, irrigation filter and water level indicator. Roofs for rainwater harvesting should use paint products approved for potable water and avoid lead, zinc and copper products that could be toxic and wood that absorb water. Gutter protection screening and rainwater head prevent leaves and debris from blocking down pipes and entering the tank. The first flush diverter discharges the first flush of contaminated water, generally the first 3 mm, to a chamber into the urban drainage system. Once the chamber is full, rainwater flows into the tank. Filters, tank screen and insect-proof flap valve protect rainwater quality. The tank is the main element of a rainwater harvesting system. It can be underground, to the ground, or on the building roof. It can work by gravity or lifting. Outside tanks projects should minimize the potential risk of freezing and algae flowering, while the use of underground tanks should consider the installation area, traffic, groundwater level, chemical, physical and mechanical characteristics of the ground. A water level indicator is required to activate the water integration from the water supply system when needed. The two main variables governing the design and the performance of the rainwater tank are rainfall regime and water demand. It's important to know the rainfall regime that is not only the total amount of rainfall but also its temporal distribution along the considered period. The amount of rainwater that can be harvested and reused is strictly related to the roof surface and coverage. The runoff coefficient, that is the percentage of rainwater that is conveyed to the tank, can generally range from about 0.9 for pitched roofs with tiles to about 0.3 for intensive green roofs. Water demand can be considered continuous and constant, such as daily requests for toilet flushing, or discontinuous and variable, such as monthly water requests for irrigation. Rainwater use for domestic uses other than human consumption requires a dual distribution network internal to the building. Rainwater harvesting systems require regular maintenance with regards to inspection and cleaning for debris and sediment buildup, inlets, outlets, withdrawal devices, overflow areas, pumps and filters. To evaluate the performance of a rainwater harvesting system, the ratio between demand and runoff volume can be considered. If it's lower than 1, high performance can be obtained even with small tanks. If it's equal to 1, there is a significant variation in performance depending on tank volume. If it's higher than 1, it means low performance despite the tank size. So, in the design of a rainwater harvesting system, a careful analysis of rainfall regime and kind of reuse should be always considered.